The following podcast is sponsored by Structure Tech.
People like to think that old houses are just bulletproof. If they've been there for 100 years, they're not going anywhere. But that's not always the case. Welcome, everybody. You're listening to Structure Talk, a Structure Tech presentation. My name is Bill Ulrich, alongside Tessa Murray and Reuben Saltzman. As always, the wobbly three-legged stool. Thanks for joining us today. On today's episode, we're going to dig into an issue that comes up rarely, but it comes up on old houses. And people like to think that old houses are just bulletproof. If they've been there for 100 years, they're not going anywhere. But that's not always the case. And this is a topic that came up recently on our internal Facebook page that we use for communicating between the team. And it was about rotted rim joists, beam fill, and old floor structure. So we wanted to dig into this topic a little bit and talk about why it happens, when it happens, any signs you might want to look for that might be indicating that you've got something going on here that needs further evaluation. So Reuben, I'm going to dump this very tantalizing topic into your lap and let you run with it.
Ooh, thank you, Bill. Fun times. This is something that I blogged about just recently, kind of in response to that internal question. It's something that I had actually been meaning to blog about this topic since 2014. So this was a really long time coming. So let's start at the beginning. Back when I was in home inspector training and I was going around house to house with my dad and with Duane Erickson, he was the home inspector in bib overalls.
Yes.
And he's since retired from home inspections, but I'd go around with him. And I remember one day we came across this house where when you look at the rim joist area at the top of the foundation wall, and just in case you don't know, the rim joist is that space kind of between floors. It's what all the floor joists kind of die into. And we're looking at it and you couldn't actually see the rim joist. It was all covered by this concrete stuff that somebody had troweled into that space. And it started at the top of the foundation wall and it sloped up at about a 45-degree angle. It completely covered everything in that area. And I was asking him, what the heck is this? The term comes from Duane Erickson. If he is wrong about this, then we are just, well, we're making it a standard. This is becoming a de jure term at this point. We say it enough and it becomes fact.
So Reuben, can I just jump in real quick?
Yeah.
You cited specifically you wanted to blog about this back in 2014. Now, why on earth does that stick in your mind?
I was wondering the same thing. It was a very specific date.
Before I blogged about it, I had to look up how old my draft was. Because I've got a draft I have probably about 50 blog post drafts just sitting there waiting to be either published or waiting to be finished written. Sometimes a draft is only going to be the title. Sometimes a draft is going to be a couple paragraphs. In this case, the draft was basically the whole stinking blog post. I wrote the whole thing ready to go, but I didn't want to hit publish until I had more information on the topic, until I had some more definitive answers. And for the next, 7 years, I've been waiting for something really definitive that we come across. I've been looking for it and I've found squat. But now when I got other people on our team asking about it, it's like, all right, I should really publish this. It's mostly for my internal team, but I'm sure there's got to be other home inspectors and homeowners and realtors out there who see this stuff and they got questions about it. So I can't find anything online. I'm the only resource I can find on this. So I thought, well, let's just give it a go. So it's
okay. So let's back up a second. They build a house this way. They've got this design. What's it for? What's the purpose of this filling that you're talking about?
The purpose is twofold. First, it's to help keep the joist from twisting one way or the other. Typically, when you build a house, you're going to take a floor joist and then you take all the floor joists and then you put a rim joist up against the ends of all of those. You nail it into place and it's going to help prevent the joist from twisting one way or the other. They're all kind of fastened in place. And apparently beam fill would achieve the same thing. You stuff that area full of concrete, and now the joists can't turn one way or the other. They're just stuck there. But not only that, If you have concrete blocks, they're going to be hollow core blocks. You never have solid blocks. You have these concrete blocks, and a bunch of that stuff is going to fall down inside the block. And it's basically going to anchor the house to the foundation. There's no way that house is going to move one side or the other. And, today we've got special straps and foundation bolts that we got to use. But back in the day, this was a very effective way of keeping the house attached there.
Was twisting joists an issue?
Apparently so. I think the technical term for that is racking, but I'm not positive. Yeah, it can happen. Sure.
Interesting.
So they'd fill the space in with this concrete, and I never thought it was that big of a deal until Duane went around house and he'd take his awl and he'd poke at all these floor joists right where they disappeared into that concrete. And Tessa, why don't you talk about this? Now we're getting into building science. Why is it a bad thing to have wood disappearing into concrete? Why don't you share that with us?
If you're picturing that foundation wall and where the rim joist kind of sits on top of that foundation wall, that concrete beam fill is kind of typically, you'll see it's like at a 45-degree angle, sloping, filling in between that space between each floor joist. And so you'll see just kind of the end of that wood floor joist disappear into that concrete beam fill. So you're describing what Duane was doing, poking the end of that wood. And he's looking to see if that wood is rotted or if it's still solid, right?
Exactly.
So one of the main concerns is that concrete is porous. And so moisture will move through concrete. Let's say you've got a stucco covered house. Stucco will absorb moisture. That's just kind of how it works. It's a reservoir cladding. I think we've talked about that on other podcasts.
Big old sponge, I say. Yeah.
Exactly. And in these old houses, a lot of old houses we have here in the Twin Cities, with this older stucco that will absorb moisture, that's then in contact with the rim joist. And that rim joist is in contact with the floor joists. And the floor joists are in contact with the concrete. And it can absorb that moisture. And also you can get moisture coming up through the foundation too, through just capillary action. You can have moisture wicking in from the exterior. You can have moisture wicking up from the foundation, from the ground. And so you have all this moisture that's moving through this kind of wall assembly. And so when you've got wood in contact with concrete, it can start to rot out the wood.
Exactly. And today, when we build a house, you don't have the wood sitting right on top of that foundation wall. We use something, I can't remember what it's called. It's just a roll of foam, basically.
Yeah. Sill seal? Is that sill seal?
Yeah, sill seal.
You want some sort of capillary break so that moisture can't move through the concrete into the wood framing.
Yep, exactly. But with the case of beam fill, you're basically doing the opposite. You are connecting it all very tightly, and you're not giving the wood any room to dry out. I mean, if it gets wet, it's going to stay wet. So often, I've been to so many homes where I would take my awl, I'd poke there, and my awl would just disappear. Like there's no wood behind it. And so often there's no visual evidence of that in the basement. I mean, the wood all looks good and it's all solid right up until the point where it disappears. And then there's just nothing there. We come across beam fill. Any home inspector should be especially vigilant to go poke, prod, do whatever you can to look for signs of damage behind there. And what prompted that blog post, what made me write about it back in 2014 was a homeowner who had me out to do a home maintenance inspection. And this is one where, it's a maintenance inspection is essentially the same thing as a traditional home inspection. We're just doing it for somebody who already lives in the house. And when I began and asked her any special concern, she said, well, the one thing was that when my heating contractor put in a combustion air duct, he said I didn't have a rim joist and he was concerned about that. And I was like, you don't have one, huh? Okay, well, we'll see. And I got down in the basement and there's fiberglass insulation all around the rim joist. It's all insulated with fiberglass. You know what? I should take a pause here. Tessa, this is bad news. You don't want to have fiberglass insulation at your rim. Why don't you share with us? Because I know you're dying to talk about this. Why is this a bad thing?
First of all, you've probably shocked like 90% of the people listening to this because that's what you see primarily at rim joists, right?
Unfortunately.
Yeah, fiberglass insulation. Well, it comes down to the building science and thinking about heat and airflow and moisture movement. And if you have fiberglass insulation at a rim joist, it adds a little bit of R value. It's not an air barrier, and it doesn't stop air movement through that fiberglass. Fiberglass acts like a filter. If you've ever, pulled back insulation in your attic around an attic penetration or something, or even around your rim joist, you can see like the fiberglass will get, this discoloration, almost this gray color around the edges. And that's basically because you've got airflow moving through that insulation, and it acts like a filter basically. And so it gets dirty. So what happens when you've got fiberglass at your rim joist is you can still have airflow getting through that insulation, but you've isolated that rim joist from the heat and the airflow in the basement. And the surface temperature of that rim joist is going to be much cooler now that you've added that insulation in front of it. It's the same phenomena of when you've got, like it's the winter time and you've got heavy drapes that you pull over your window, right? Feels warmer in the house, but now you've isolated that glass from the heat and the airflow in the room. And so you're still going to get some moisture and some airflow through that curtain, and you'll get a lot of condensation on the glass, right? Because the glass is so much colder because you've pulled that heavy curtain over it. So same thing happens with a rim joist. You put fiberglass insulation in front of it, you make the surface temperature of it colder, and you still have moisture getting through there. And you can have moisture getting through from the other direction too. We'll talk about that later, but you reduce the drying potential of it as well, just because you've got a material blocking it from drying. And so you can get this condensation that builds up behind the fiberglass, and it can create lots of problems. A lot of times if you pull that fiberglass back, you'll see mold, or it'll be wet, or there'll be some sort of like microbial growth happening there on the rim joist. So the best way to insulate a rim joist would be to use some sort of product that is in contact with the actual wood, that acts as a consistent thermal boundary and air barrier in the same plane, so that they're aligned and continuous, and you can't get airflow behind that insulation. So like either rigid foam that you caulk around all the edges and air seal it perfectly, or what you see most commonly is like a closed cell spray foam that's sprayed directly to the wood, so that you don't get an air gap between that. Moisture can condense and rot it out. So that's what we see in new construction a lot.
Yeah, for new construction, boy, I can't think of exactly what age, but I gotta say mid 2000s and after, I haven't seen anything but that used. I mean, bar none.
I want to add one little thing, that we're talking about insulating your rim joist, and to use closed cell spray foam and rigid foam, it's way better than the fiberglass. But there is a concern. You can create unintended consequences if you try to insulate a rim joist with closed cell spray foam or rigid foam in an older house where you've got a situation like beam fill or some sort of concrete that's in contact with the wood, where you don't have some sort of capillary break between the wood framing and the concrete. It can make that moisture problem even worse because of the things we just discussed. If your wood is buried in the concrete, that moisture can move right through the concrete, through the foundation, and into the wood. And what happens when you air seal that rim joist from the inside? Now there is zero drying potential for that moisture to move through the wood and dry to the inside of the house. So you put like a Ziploc bag over the exposed part of wood that used to be able to dry out, and now it can't anymore. And so you've actually sped up that process of rotting out that framing.
You're no fun at all, Tess. I can just say that. You are a wet rag. And, and to play devil's advocate, let's say you got a house that's 80 years old. It's been that way for a long time, and you don't have beam fill. You just have the joist sitting on top of the foundation wall. There's no insulation there at all. And you've never had signs of moisture, any of that at the outside. You have a relatively dry basement. Would you have any reservations adding spray foam at your rim joist?
I guess as a building scientist, I would say there's always a potential risk. Exactly. It's not a yes or no, right? Anytime you take something that has been okay for 100 years and you change how it performs and you reduce its drying potential, then yes, there could be a risk at
All
some
right.
point.
I should have known you'd say that. I should have phrased my question differently. Let me say this again. Tessa, would you do it? Would your concern be enough to prevent you from doing it?
Actually, it would be. You know what? Here's the trade-off. You have a house that has been working fine without that added insulation at the rim joist for 100 years, and now I change it and I add that insulation. How much money does it actually save me, in the long run in terms of heating costs or cooling costs to spray that rim joist? And what's the risk involved with creating some sort of rot or mold? To me, I'd rather pay the extra money in heating and make sure that it stays dry and I don't have structural issues than to save a little bit of money on heating costs and potentially risk rotting something out. That's just me.
Bill, you want to chime in?
Well, I've been very quiet for several minutes here, and that's because I was in my basement removing the fiberglass insulation between my joist cavities that sits on top of the core fill. So I'm basically terrified that my house is going to fall in on itself. And everything I said is true. I do have fiberglass insulation in between my joists, which does have this core fill that you're talking about, or beam fill. It's not core fill, it's beam fill. Sorry, I didn't want to bum anybody out. But you know what? I don't care, because it's not going to ruin my house. And if it does, it'll happen after I'm long gone.
All right.
You know what? Actually, Reuben, I was just going to say, so if the rim joist does rot out, which does happen, and I've seen before, actually, I think I was doing an inspection with you. This is back when I was in training. And do you remember this? We're doing an inspection on a house in South Minneapolis, and I think it was a single item inspection or something like that. It was a woman who owned it that had us out there.
And all the siding was gone, right?
Yes, she was putting new siding on. She had a problem. I think she was having a problem with flying squirrels that remember they were eating through her siding.
You guys are kidding now. This isn't even a real story.
No, I'm not kidding.
I totally remember.
Yes, and you remember you lift up the Tyvek that was wrapped on the outside of this house, and you could see where the foundation transferred to the wood framing and where the rim joist should have been. And what did we see?
Now that I don't remember.
Oh, you don't? Okay.
Oh.
We should post a picture. I know we've got a picture of this somewhere in our database, but you could see that the rim joist had rotted out completely. And you could see poking through the beam fill like a little bit of wood from the floor joists in the basement, but they were rotted. And so I asked him, like, there's no rim joist here. It's rotted out. It's gone. Like, I'm looking at the floor joist coming out through this beam fill. Is this a concern? And you're like, well, the beam fill is kind of taking the place of the rim joist, and the beam fill is now the structural support of the wall. And I think what you recommended was, this is probably okay, but I don't want to put my stamp of approval on it. I'd recommend having a contractor come out here and okay it before they reside it. I think that's what you said.
That sounds about right. And I mean, boy, we got so much to get back to. We keep going down these trails. I want to address what I would do with my rim joist. Before that, to answer your question on this, I got to backtrack even more. So 2014, what prompted me to write this blog post going all the way back to the beginning was that inspection I was doing. Let me fast forward. We got a lot to remember here, but I want to give a good answer to your question about what I recommended. So this woman had fiberglass insulation at her rim joist. I pull the fiberglass back. I find beam fill, and I go poking and prodding, and I get permission from her to really get aggressive. She's like, get a hammer, bust it out, do whatever you can. All I had to do was get my awl, kind of shove it in there and pry it. And I was able to kind of break a section of that beam fill out to find what used to be a rim joist. She had a rim joist. There was remnants of one, but behind it was just the stucco. I mean, it was completely gone. And there were carpenter ants all over her basement. And I said, yeah, you should get with a contractor to help you fix this. And they agreed she didn't need to replace her rim joist. It's good enough. Things are going to stay where they are, but the ends of her floor joist were rotted. So they did end up removing all of the beam fill, and they sistered all of the floor joists that had rot. And I think the cost, if I remember right, it was somewhere in the neighborhood of $4,000 to $5,000 to go around and sister up a whole bunch of floor joists and get rid of all the beam fill. So, it wasn't a tear your house down type of thing. it also wasn't a 100% complete repair.
Yeah.
But to tie it back to what you're bringing up about this inspection we did a while ago, I suspect that if there were rotted floor joists, a contractor could have simply come in and sistered them up and left it alone without actually replacing that rim. That's my thoughts on it. But yeah, we'll have to dig up photos of that for sure.
Yeah.
Yeah.
Okay, so I have some questions just for perspective. How often do you think this is a concern in these old houses?
Well, wait, before we address that, Bill, let me get back to this thing that Tessa was talking about, because Tessa's saying that she wouldn't do it. She would not insulate her old house with spray foam insulation. Now, for me, I would. I
take
would
the risk.
I would take on that risk.
Yeah.
And for me, I'd take it on because I don't think the concern is that high. I don't think a lot of houses actually end up having problems with this. I mean, I understand, Tessa, you're right. You certainly have the potential for this. I personally have not found it ever happen. And for me, it wouldn't be so much about the energy savings. It would be about the comfort. And I say that as somebody who has lived in a really old house with really leaky rim joists. And I know that those outside walls and the floors tend to get really cold. It's uncomfortable. It really is. And on my last house, which was a 1998 built home, after living there for some time, it wasn't quite a year, I'd hired a company to come in and insulate all of my rim areas and all of the outside walls on my walkout basement. They totally spray foamed everything. And I mean, just like that, it made a huge difference overnight where my house was way warmer. My outside walls felt way warmer throughout the entire winter. And about 2 years ago, I moved into a house that was just a little bit newer. The house I'm in now is a 2002 built home. And I have fiberglass insulation at the rim joists at this house. I have a fully finished basement. And I'll tell you, this house is colder than my last house. When it is cold outside, I have to turn the thermostat up to like 73, 74 degrees to really be comfortable here. And at my last house, I felt comfortable when it was about 70 to 71 degrees. Even though I might not get a huge payback from the energy loss right at the rim joist, there is a big difference in the comfort. And to me, it's worth a lot. If I didn't have a finished basement, I would go ahead and insulate the heck out of my rim joist with spray foam right away.
You know, that's the conundrum with building science. It's like comfort versus durability, right? You can't always have both. So what is a priority for you as a homeowner?
Exactly.
There's no right answer.
Okay, so Tessa, that prompted a question in my head is that always a sliding scale? Tessa, can you achieve durability and comfort, or is it a sliding scale? You give up one to accomplish the other.
You can have both, Bill. You can have both, but it takes planning and it takes a good design, good execution, and, you know, occupant behavior that's responsible. But it gets tricky when you're dealing with a situation where you can't choose the materials, they're already there, and you can't choose how it was designed. It's already put together. So like in these, 1900 houses, a 1920 built house where you've got the wood framing buried in concrete, you can't add a capillary break, right? You can't stop that moisture migrating into the wood from the foundation or through the exterior wall. It's just going to happen that way. So in this situation, it's kind of like pick one or the other. But if you're designing your own house, then with new construction, we have capillary breaks at, the foundation to the rim joist and all these things in place so that we don't have those issues. And so spray foam is less of a risk at the rim joist in that type of design.
I just look at my own house and I know if I went around and spray foam my entire rim, it won't make a lot of difference because the heat supply comes from the inside of the house. Reuben, in your new house, it comes from the rim area and migrates toward the center where all the returns are at. My house is set up exactly the opposite. All the heat's delivered from a central elevator shaft, essentially. And if it gets out to the outside walls, well, that's a good day. So there's an oversimplification that we always have to understand where, to your point, Tessa, what's the design feature of the house? And I agree with you, Reuben. Your house is probably more comfortable. I'm just thinking at my house, if I did the exact same thing that you did to your house with spray foam at the rim, my needle's not moving a bit, where you saw a huge difference. So every single one of these has to be judged on its own merit.
Yeah, the thing is, it's interesting. Like whenever you take a house and you change it, you add more insulation, you do more air sealing in the name of improving comfort or energy efficiency, you have to think about how it could potentially create these unintended consequences and reduce drying potential or create problems with air quality or combustion safety, how all these pieces fit together. And Bill, like you said, I think, older houses, they were just in general a lot less comfortable because they weren't airtight and because they weren't well insulated. You'd use a lot of energy to heat them. And that's just the way it was, right? People would put on, another layer in the wintertime and know that their house would feel drafty. And when they sit near next to your wall, it's going to be cold. And that was just what people were used to, right? But as houses have gotten more efficient and we've added more insulation, done more air sealing, our expectations are much higher for what comfort means and what we expect in houses today. And so it's hard when you've got these older houses that don't meet people's current expectations, and they do these improvements thinking that they're doing good to these older houses, make them more comfortable, but they're unaware of these potential durability issues and air quality issues that they're creating when they make these improvements.
Drop the mic.
Hire a building scientist. If you're going to be changing any house, old or new, and doing these things that can impact the way it performs, you need to be thinking about the whole system. You need to be thinking about the house holistically.
Okay, I want to go back to the rotten rim joist in Minneapolis. What was the exterior cladding on that house?
Stucco.
And did that exterior, it was stucco. Do we see stucco houses having this problem more frequently than we see a wood-sided house having this problem?
I haven't seen enough of it to intelligently answer your question.
And so is this something that you run across on 1 in 250 old houses? Is it 1 in 150? Is it 1 in 50? Is this a major problem, or is this one of those Easter eggs that you find on your home inspection?
Are you talking about beam fill or rotted rim joists?
The whole story playing out as it was laid out. There was something here that led you to start digging on that particular house that opened up this proverbial can of worms.
Sure. I don't know, Bill.
You know what I think it
All right.
was? I think it was just the fact that this house, she was preparing to put new siding on, and the house just had the Tyvek on it still. And Reuben, doing what you do, you were just kind of, you lifted up a little bit of Tyvek to see kind of what was underneath it. And that's when it exposed the fact that there was no rim joist there. So just because it was accessible, and you could look, so you did.
Okay, so now I have a follow-up question. You can see the rim joist from the outside when you're putting Tyvek on. Who's the clumsy carpenter who's just said, well, that's good enough?
We'll Tyvek over it. It's fine.
I mean, the
Yeah.
time to address it is in situations like this,
Yeah.
but that doesn't fix the why behind it. I'm just always curious because I think these conversations are multivariable, and which makes them fun because, simple algebra is pretty easy, but complicated equations.
Well, we didn't even talk about, Reuben, there's another potential thing that I've heard, and I don't know if this is true either, that could cause a rim joist to rot out. And it's not due to beam fill or reduced drying potential because of it from ice dams. Have you
Yes.
heard that too?
Yes, I've heard that theory from other home inspectors saying that, you've got ice dams and you got water leaking in at the outside of the house, water's running right down the wall, and then it hits the rim joist and it rots it out. And it's a plausible theory, but I haven't seen the evidence to support it, because I have come across these homes with beam fill where you have rotted walls at gable end walls. And when I say
Yeah.
gable end wall, I'm talking about take your hands and make a tent with your hands, and it's the wall where you don't have a roof slope terminating. It's the end wall. So if you have leakage from ice dams, that water is never going to reach that gable wall. And if
Yeah.
I see the gable wall rotted out, it tells me it ain't ice dams that's causing this. It's
Mhm.
impossible. I'm sure ice dams could cause the rotting of that rim joist, but when you've got beam fill, I'm saying it's a building science issue. It's not ice dams.
Mhm.
But good point.
Are open core blocks more likely to cause this problem than, say, a poured concrete foundation?
I don't know.
Because, I
That's a
mean, in
good
theory,
question.
you could have vapor in
Mhm.
air rising up through the cores, hitting
Mm.
that wood from below and accelerating that process, right? Like
Well,
you don't need
yeah.
physical wet water. You could have, will water
Mhm.
vapor cause rot?
Yeah, I mean, it can increase the humidity level and yeah, it could still create some moisture problems. But I mean, if you've got a solid concrete or poured foundation and wood is buried in it, then I mean, that whole foundation, you can have capillary action or wicking through that foundation in the wood. So yeah, open core can have rotted floor joists, with the beam fill, and so can a poured concrete foundation. I've seen it in both.
Okay, well, I think we've covered this topic in exquisite detail. Okay, I think let's put a bow on this conversation. As you can see, obviously, sometimes you got to look a little bit deeper. And it's just knowing where you're getting into layers of concern, right? I think we've done as much as we can do with this conversation. So good stuff. It's nice to know there are some challenges out there that you wouldn't normally think about. And it's not as if these beam fill joist cavities were something that ended at a very specific time. It's not like knob and tube. Okay, so you can see these laying around all over the various decades of building out there. But thank you, Reuben, Tessa. Appreciate all your knowledge and stories about beam fill and rotted rim joists. Thanks, everybody, for listening. You've been listening to Structure Talk, a Structure Tech presentation. My name is Bill Ulrich, alongside Tessa Murray and Reuben Saltzman. Thanks for listening. We will catch you next time.
For more information on how we can provide you with the right information about your home before you buy or sell, contact us at structuretech.com.